All right, 25. So we have three identical charges. They're all negative. So this guy's a negative charge. This guy's negative. That guy's negative. Now look, I like to number the charges so then we can talk about them easier. So we're going to say that this guy is charge number 1. This guy's charge number 2. This guy's charge number 3. Okay? Now, we're focusing at the midpoint of the circle, and we're being asked to find the total electric field at that point. Okay? So for starters, you have to identify the direction of the electric field for each of the charges, right? Because how many charges are contributing to the total electric field at this midpoint? 3. Okay, so what do we know about negative charges? The electric field goes in, right? In all directions, like this. In, and then what's the reason for that? Why does the electric field go in to big negative? Because what's the electric field based on? A little positive dude. And by the way, guys, are these three charges here, are they big dudes or little dudes in this problem? They're big dudes. How do I know that these charges are big dudes? Because what are they doing in the context of the problem? Are they experiencing a force from another field, from an existing field, or are these charges creating the field? They're creating the field. So these are big guys, right? Okay. So at the point we're focusing on, what's the electric field from charge 1 doing at the midpoint right here? The electric field is going that way, right? So we're going to label that E1. Okay, charge 2 is negative. Electric field goes in all directions like this. So what's the electric field doing at the point we're focusing on from charge 2? The electric field due to charge 2 at the midpoint of the circle is going that way, right? E2. Okay, charge 3 is also negative. Electric field's going in like this, okay? So at the midpoint of the circle, which way is the electric field from charge 3? Going straight down like that. So basically, we have this. So here's the midpoint of the circle. We have E1 like that from charge 1. We have E2 like that. We got E3 straight down. And then this angle in here is 30 degrees. This angle in here is 30 degrees. Okay? Now, if you look at this, you can, if you're really paying attention, you can recognize that the answer is going to be 0 at this point. And here's why. Here's why you can recognize the answer is going to be 0. But I'm going to solve it as if we didn't know that. Okay, so E1, we can break it into X component, Y component. E2, we can break into X component, Y component. Now, what do we know about these three electric fields? Are they the same or different? They're the same. Why are these electric fields going to be the same? Well, all three charges are what? The same. And then how about the distances? The distance, look at, what's this distance here? 2 meters. What's this distance here? 2 meters. What's this distance here? 2 meters. And by the way, what's the equation? What's the equation that applies here for finding electric field at a distance from a big guy? KQ over R squared, right? So the charges are the same, the distances are the same. So these three electric fields are all identical, right? So look what's going to happen. What are these two X electric fields going to do? They're going to cancel, right? They're equal and opposite, okay? And then look, this happens to be 30 degrees, right? So what's sine of 30? Sine of 30 is what? 1/2. So here you have half of of the electric field up. Here you have half of the electric field up. Here you have the total electric field down. So what's going to happen to these three Y electric fields? They're going to cancel. But let's just pretend we didn't recognize that. So here's what you would do. You got to calculate these electric fields. When you plug in, you know, so K is 9 times 10 to the 9th, Newton meter squared over Coulomb squared. Make sure you put charge out of, like, so what's micro here? 10 to the negative 6. So don't go like this. Is that going to work? You got to put it in coulombs. So 5 times 10 to the negative 6 coulombs. And then R is 2 meters squared. So this comes out as 11,250. 11,000, they're all 11,250. 11,250. Okay? But like I said, when you look at this, here, so how would we show this? Everything's going to cancel. So what you do is you're going to find your total, you're going to sum the electric fields X. So you would go cosine 30, like this guy right here. Cosine 30, 11,250 minus cosine 30, 11,250. That's this guy here. What's that going to equal? What's the total X electric field? 0, because they cancel. Then you go to the Y direction. Sum your electric fields in the Y. So you got 3 Y components. This is just vectors. This goes back to chapter 3. So you're going to go sine 30, 11,250 plus sine 30, 11,250, right? Because there's 2 of them. You got this guy and you got this guy. There's 2 Y components. Then minus 11,250, which is this guy. And then that all adds up to what? 0. So what's the X electric field? 0. What's the Y electric field? 0. Hey man, if we stuck a proton at that point, so imagine you took a little dude now, say that this guy right here represents a proton, how much force would that proton experience? 0. What's the equation for finding force on a little guy in the field? Force of an electric field equals QE, where that's the little guy, right? That's the little guy. Well, what's the electric field at the midpoint? 0. So the force would be 0. Okay?